Okay, this is section 2.5, and it's called Implicit Differentiation. So far, we've learned lots of different rules: power rule, chain rule, product rule, quotient rule, to find derivatives. And this whole time we've been finding derivatives, we would write something like this: d over dx, which means find the derivative with respect to x of, I don't know, 3x squared. Okay, and so when we found the derivative, we knew that our answer was 6x, and we knew that x, because I'm taking the derivative with respect to x, should be my variable. Okay, so what if we have a problem that's not in terms of x? So this equation right here, y cubed plus x cubed, this big long equation, this is an implicit equation, and it would be really hard to solve for y in this equation, okay, so that we could take the derivative. So when we have an equation like this, when you can't solve for y, we're going to do what we call implicit differentiation. Okay, and in order to take the derivative of an implicit equation, you must use implicit differentiation, and we're going to do that by finding the derivative with respect to x. So when we differentiate terms involving only x, you can differentiate as usual. So all the problems that we've done so far just involved x as our variable, and we didn't have to do anything special. So now when your equation involves x's and y's, we're going to use implicit differentiation, which is actually an application of the chain rule. Okay, so you guys are going to like this because it's just basic steps that you follow. All right. So first of all, I know I'm going to use implicit differentiation when I have x's and y's in the problem. So the first thing you're going to do is take the derivative of both sides of the equation with respect to x, combine all terms with y prime, or another way to write y prime is dy dx, on the left side, and move all other terms to the right side of the equation. We're going to factor out a y prime and solve for y prime. Okay, so it sounds like a lot, but once you see how it's done, it's pretty easy. Okay, now, so I'm given this equation, and I'm supposed to find y prime. Well, you can see I have to use implicit differentiation on this because I can't solve this for y. I have x's and y's in my problem. So here's what you're going to do. Okay, I'm going to take the derivative of this with respect to y. That's going to be 3y squared. But then when I take the derivative with respect to y, I can't do that. So now I have to take the derivative of y with respect to x. So dy dx. All right? Plus, take the derivative of this, 2y. But now I have to write it as the derivative with respect to x. Minus, the derivative of this is 5, but that was in terms of y, so I'm going to write dy dx. The derivative of this, now this is a good one. It's in terms of x already, so that's just minus 2x. Equals, the derivative of negative 4 is 0. Okay, now here's the deal. Some teachers make you write this dy dx the entire time. Dy dx, I usually write that as just y prime, just because it's shorter and it's not as messy. Okay, so in our problems, instead of writing dy dx all the time, let's change that to y prime. But I want you to see that because a lot of books and a lot of teachers will write dy dx instead of the y prime. So now I'm going to go ahead and change this just so it's easier to see. Okay, 2y y prime minus 5y prime minus 2x equals 0. And another reason why some people go ahead and write that dy dx is so that you can see that you took the derivative with respect to y, and now I had to take it with respect to x. All right. So now I did step 1. Okay, I took the derivative. Now we're going to combine all terms with y prime on one side, anything without a y prime on the other side. So this is going to stay, this is going to stay, this is going to stay. I need to move this over. So I have 3y squared y prime plus 2y y prime minus 5y prime equals 2x. Now if I'm solving for y prime, because that's what it told me to, each one of these has a y prime, so I'm going to factor out a y prime. So when I do that, I have 3y squared plus 2y minus 5 equals 2x. Now if I'm solving for y prime, I'm going to divide by all of that on both sides. So y prime equals 2x over 3y squared plus 2y minus 5. And that's my answer. Okay? There's really no simplification I can do. I'm going to leave it just like that. All right, so let's do another one. Find y prime. Okay, first of all, I know this, I could solve for y for this, but when I solve and take the square root, I have a plus or minus involved. So I'm going to use implicit differentiation. So I'm going to find the derivative of the x squared. So that's already in terms of x, so I just 2x minus the derivative of y squared is 2y, but since it's not with respect to x, I would normally write dy dx, but we're just going to put y prime equals the derivative of 25 is 0. So the shortcut to remember is when you're doing implicit differentiation, I know I'm doing implicit differentiation because I have x's and y's. Anytime you take the derivative of something that has a y with it, you have to write a y prime next to it. Okay, so that's the shortcut to remember. Anytime I take the derivative of something with a y, y prime goes with it. So now I'm going to solve for y prime. Subtract 2x, negative 2y, y prime equals negative 2x. Divide by negative 2y. Y prime equals, my negatives 2 cancel, x over y. Okay, example 3. All right, I'm going to go ahead and write this out. I have x squared y plus y squared x equals negative 2. Now here's the deal on this one. They're going to start combining rules on you. I'm going to do implicit differentiation, but this is x squared times y. This is the product rule. Here's my first term, here's the second term. Same thing with this. Here's my first term, here's my second term. So I'm going to do this. Product rule says first term times the derivative of my second. Well, the derivative of y is just 1, but since it had a y with it, I have to put 1 y prime, or I'm just going to put y prime. Plus my second term times the derivative of the first. So this right here is the derivative of that part. Now let's do the derivative of this. Plus, I have to do the product rule again. First term times the derivative of the second plus my second term times the derivative of the first. Derivative of y squared is 2y, but it had a y with it, so it has to be y prime. Equals derivative of negative 2 is 0. Okay, so I'm just going to kind of fix this a little bit. I have x squared y prime plus 2xy plus y squared plus 2xy prime. Now if I'm supposed to solve for y prime, I need my y primes on the left, anything without a y prime over on the right hand side. So I'm going to move these two things. So I have x squared y prime plus 2xy prime equals negative 2xy minus y squared. Now if I'm solving for y prime, I'm going to factor a y prime out. And I have x squared plus 2xy equals negative 2xy minus y squared. Divide by that. And I get y prime equals negative 2xy minus y squared all over x squared plus 2xy. And that's my answer. Okay, my next one. Find y prime given cotangent y equals x minus y. All right, so first of all, if you don't know what the derivative of cotangent is, it's on your sheet, one of your note sheets with the derivatives of all the trig functions. The derivative of cotangent is negative cosecant squared y. Now this had a y with it, so I was taking the derivative with respect to y, so I need to put either dy dx or we're going to put y prime. Equals derivative of x is just 1 minus derivative of y is 1, but it had a y with it, so it's 1y prime. Now, I need my y primes on the same side, so I'm going to take this one over here. So I have y prime minus cosecant squared y prime equals 1. Factor a y prime out. When I factor a y prime out here, I have 1 minus, and I should write a y next to that, cosecant squared y prime. So cosecant squared y equals 1. So y prime equals 1 over 1 minus cosecant squared y. Now, I would take this as your answer. In the back of the book, here's what they're going to do. They're going to say, remember your Pythagorean trig identities? 1 minus cosecant squared y is the same thing as negative cotangent squared y. And then they're going to say, well, 1 over cotangent is really tangent squared y. So in the back of the book, they will probably have this. If you got that part, that would be sufficient. Okay, example 5. Find dy dx and evaluate the derivative at the given point. So we're going to find the derivative. The derivative of x squared is 2x minus derivative of y squared is 2y y prime. Derivative of 0 is 0. I'm still solving for y prime, so I'm going to subtract 2x. Negative 2y y prime equals negative 2x. Divide by negative 2y. So y prime equals, my negatives 2 cancel, and I get x over y. But now I'm supposed to evaluate at the point 1, 1. So when I plug the point 1, 1 in, I get 1 over 1, so the slope is 1. Okay, example 6. Okay, find dy dx and evaluate the derivative at the given point. So I'm going to write this down. You should recognize that this is the product rule. Here's my first term. Here's my second term. So product rule says first term times the derivative of my second term. The derivative of cosine is negative sine. It has a y with it, so I need a y prime. So the first times the derivative of the second plus the second times the derivative of the first, and then equals the derivative of 1 is 0. So I'm going to kind of fix this. This is actually negative x. I'm going to bring that negative out in front. Y prime. This doesn't have a y prime with it, so I'm going to go ahead and move it over to the other side. So negative cosine y. I'm solving for y prime, so I'm going to divide by negative x sine y. So y prime equals, I have a negative over a negative, so that's going to be positive cosine y x sine y. Okay, so now I have to plug this point in. So let me change colors so we don't kind of get everything mixed up. So I'm going to do it up here. Y prime equals cosine y, but y is pi over 3, over x, which is 2, times sine of y, which is pi over 3. Cosine of pi over 3. Cosine pi over 3 is 60, so the cosine of 60 is 1/2. I'm going to put divided by, because I don't like fractions over fractions, 2 times the sine of 60. The sine of 60 is the square root of 3 over 2. So I have 1/2 divided by, my 2's cancel, square root of 3. 1/2 times the reciprocal. So my answer is 1 over 2 square root of 3. Okay, now your assignment is on the front of your page. I didn't write it on this, but it's on your note sheet. And you're supposed to do, part of your assignment is numbers 45 and 57. So I'm going to go ahead and do those with you. Now on 45, I'm supposed to find, this is the symbol for the second derivative. Okay, so I'm going to go ahead and find the first derivative. First derivative would be 2x plus 2y, y prime equals 0. And then I'm going to go ahead and solve for y prime. So I have 2y, y prime equals negative 2x. Divide by 2y. And I have y prime equals, my 2's cancel, so I have negative x over y. Okay, so that's the first derivative. So now I need to find the second derivative. So here's the first derivative. So that means I need to find the second derivative. I'm going to find the derivative of this answer. This is the quotient rule. So y double prime equals, quotient rule says, bottom term times the derivative of the top minus the top times the derivative of the bottom, which is 1, but it has a y prime, all over bottom term squared. Now I'm going to fix this a little bit. That's negative y plus xy prime over y squared. Okay, now here's the problem. I have y prime in my answer. I can't leave y prime in my answer because I know what y prime is. It's negative x over y. So I have to substitute this negative x over y in place of this right here. So I have y double prime equals negative y plus x times y prime, but that's negative x over y, all over y squared. Okay, so if you got that far, that's kind of good, but let's fix it a little bit. Negative y, that's minus x squared over y. Okay, divided by y squared. If I'm going to simplify it, if you got this, that's good, but I'm going to show you how to simplify it. Now I need to find a common denominator, which is y. So if this is 1, I need to multiply the bottom and top by y, so that would be minus y squared minus x squared times this reciprocal, 1 over y squared. So if I looked this answer up in the back of the book, they would probably have this. Actually, I know that what they have. Okay, but they have this. Tell me if you know how they got this. Let me see real quick. They have this. So if you can tell me how they got that, I'll give you extra credit. All right, last one. Number 57. Find the points at which the graph of the equation has vertical or horizontal tangent lines. So first of all, I know that there's a vertical tangent line when the derivative is undefined, where the slope is undefined. And I know there's a horizontal tangent line where the slope is 0. So let's find the slope of this, which is the derivative. So the derivative of this would be 50x plus derivative of this would be 32y prime plus derivative of this would be 200 minus derivatives would be 160y prime. Derivative of 400 is 0, so equals 0. Okay, let's solve for y prime. So I have 32y prime minus 160y prime, and then I'm taking everything else over to the other side. Factor out of y prime. 32y minus 160 equals negative 50x minus 200. And now I'm going to divide by that. So here's what I have. All right, so there's my slope. So let's find the vertical tangent first. So to find the vertical tangent, so vertical tangent. I know vertical tangents are where the slope is undefined. So this is going to be undefined where the denominator is equal to 0. So I'm going to say, okay, 32y minus 160, where is that 0? Well, 32y equals 160, divide by 32, and y would equal, what is that, 5. So I know I have a vertical tangent when y is 5. Okay, if we wanted to figure out what the actual point was, I would plug 5 into this equation, into my y, and solve for x. Okay, now, where do I have a horizontal tangent? Horizontal tangent is where the slope is 0. So here's the equation of my slope. Set that equal to 0 and solve. Okay, well, how do I solve that? I usually cross multiply. So when I cross multiply, I get negative 50x minus 200 equals 0. Cross multiply. So negative 50x equals 200. So divide by negative 50. X is equal to negative 4. So when x is negative 4, I have a horizontal tangent. Okay? All right, your assignment is on your note page.